If you look around you, you might have noticed that every object, particle, thing is either resting on something or is connected to some other surface. So instances of the books on the shelves, instances of the stones on the ground, dust on the objects, instances of trees in the forest, or people walking on the streets. So some surface or the other is guiding these instances, their position and rotation. So similarly, the components of the 3D meshes are not just to build surfaces and render things out, but these components, the vertices, edges, polygons, quads, these components can help guide other instances in the scene, scatter things around and generate points to build up much more organic and complex looking distribution of objects. So it would make perfect sense if we take the same approach when detailing the 3D world instead of manually placing things around. So when dealing with the complex scenes, instead of manually populating the scene, it's much easier and practical to distribute objects with point scattering and instancing, which won't give you the finest control you need to adjust each and every object's position or rotation, but can make life easier to arrange millions of objects with a bigger strategy. So welcome back to another chapter of the Blender's Geometry Node Introduction series. This is Ram from Crossmind Studio, and in previous chapter we discussed how to use vector math and simple math functions plus the textures to modify the shape of a mesh with geometry nodes and create this simple displacement effect. And today we are going to talk about a few basics of object instancing on the points. So in further chapters we can combine both of these together to create maybe a scene of forest or something. So before we begin, I would like to thank the sponsor as well as our rendering and cloud workstation partner for this series, Rendero. If you are a student and professional who can't afford a powerful computer, then check out Rendero. They offer cloud-based workstations capable more than enough to handle complex heavy 3D and VFX tasks on a very affordable prices. We also did our detailed video and comparison in the past, so do check that video out. Link is right here, and use the code mentioned in the description to get the discount when signing up. So let's begin with the tutorial now. I have Blender 3.0 Alpha, the beta version of the Blender 3.0, and we have this very simple ground plane on which we are going to scatter things. So let's click on the new node network in the geometry node editor and give it any name if you prefer, the cube, MoGraph, anything. Instead of this plain's geometry input, I'll bring in the mesh primitive grid, and this gives us much more flexible options to increase or decrease the vertices and everything later on if you'd like. So I'll just increase these numbers. Let's give it any random number, and so just go to the add menu and find this category called instance, and there are many nodes available to modify and add instances. So it's going to be a combination of points and instances, and the points are not just into these two menus. You can find it into curves. If you're dealing with the curves, you will be able to find the curves to points here, and if you're dealing with the mesh, then mesh to points here. So I'll bring in instances and instances on point. So everything disappears, and it doesn't, Blender as of now, it doesn't shows you any visualization of points for this node, and that is not really ideal, but we'll work with it for now. So let's bring a cube. On this plane, I would like to scatter this cube, but this cube is too big, 0.001, sorry, 0.01, 0.01, and 0.1. So I'll keep it something like this and plug this into instances so that I have this grid now. And all of these vertices are replaced with this cube. And just like previous chapters, we can join geometry, the original state of the geometry, and get access to both. So I have this plane, I have these bars now. So it's a good start. Now I'll just disconnect this for now and just want to discuss something. So in previous chapter, what we did was geometry set position. Yeah. So when we were working with the math nodes in the previous chapter, so I just create the same example very quickly again, and texture, Musgrave texture. Yeah. So this is what we did in the previous chapter. Sorry. Yeah, combine XYZ. We just want the displacement in the Z direction. So I'm not going to get into the details of the steps. So just follow the previous chapters in the right order. If you feel lost at any of the moments, something if I'm not explaining here, that means it's already either explained in the previous chapter or will be taken care of in the future chapters. So now this is what we used for the displacement. So what if instead of using this grid plane, we use this geometry input to instance these bars? All right, so let's do that and see what happens. So I disconnect this one, this grid input which was going to instances, and instead I'll take this input off from the set position and plug this into points. And now all the bars are displaced just like the original plane. So if we can use the vectors and these math functions and the textures to displace the points of the plane, then it's pretty obvious that we can use the same thing to affect the rotation and the scale and any other parameters which are vector and the factor based. All right, so most of these, not everything. So we do the same thing. Let's bring the vector math node. So instead of creating the displacement on the plane, we'll create the height variation on these cubes with the Musgrave texture, sorry, noise texture. So I'll add into scale, and since everything is 0, 0, 0 now, everything disappeared. All right, so just plug in your texture into the vector. So now we have some height variation going on. So we can modify this texture to bring in any sort of the pattern, the waves, the scale, detail, anything you prefer. All right, you can bring in more math functions like utilities and map range or math nodes, just to exaggerate the effect of the material, the texture with the multiply node. And you can also do the map range and play around with these settings. So you can define the highs and lows of this the texture which is affecting the scale. So that is all which is there to create this cool looking graph animation. And I'll bring in a value and make this texture into 4D. As we discussed in the previous chapter, to create a frame based animation, you can simply bring in frame, and this will give you the current number of frames. And when you play the animation, this parameter will keep on going. So you plug that into the time value and you will have this animation, which is pretty fast. So divided by 600 and you get this nice animation. So pretty easy, right? So we are going to keep it simple because for some of you it might be easy, for some of you it's going to take some time. I took some time to understand this, and even just yesterday I was just chatting with the team on the Blender to troubleshoot very basics. So it's never enough. You can always get stuck with the situations. So we have this node animation going on, and from here on you can keep on detailing. Like you can maybe try out different textures. Instead of a noise texture, what if we bring in a Musgrave texture and plug this into here? So now you have different kind of texture going on. Also combine multiple textures, just like what we do in the cycles to create more complex looking. So let's plug this into detail and see. Now you can control the detail part with another texture, or maybe you can plug this into vector. And you have this different looking pattern texture going on, which is slightly different than the original texture. All right, so I'm just going to tweak on few settings here and there and find the perfect balance that I'm looking for. So this is one layer of instances. Now the fun begins when you start layering your the instances with another layer of instances. Like I said, there is no end to it. What you can do is scatter more points on top of these bars and maybe some small spheres, and on top of that you can add another layer. So that's what we are going to discuss now. Let's just arrange these nodes in something that we can understand. Now let's pause the animation, and so on top of these bars, let's go to the mesh and mesh to points. Let's plug this one here. Sorry, I'll just mute this one with M for now, and I'll just clean this off with the Shift F so that it doesn't interfere with the rest of the things. So we have this mesh to points and 0.01, yeah, 0.005. So now on every bar we have these points. So instead of vertices, I'll choose the faces. So on every face we have this, and plug the original input into the joint geometry. All right. But the problem right now is on every face I see the point, the top face, the bottom face, the side faces. What I would like to do is only the top faces should have this point on which later on I would like to scatter a sphere or an orb or something. The good thing is that we have an option for that. But before that, let's just go to the instances and click on the instances on point and bring one simple icosphere so that we can see something good looking instead of point. Maybe increase the subdivision if your computer can afford it. Now if you notice in the mesh to points, there is a selection input, and what this is asking for is basically on which faces you want to scatter the points on. If you don't use anything here, it's going to basically consider the entire geometry of the mesh and scatter things everywhere. In our case, what we need is, let's bring the normal input. Now we'll talk about the selection methods in one of the dedicated chapters, maybe the next chapter or the chapter after that. There are no group nodes as of now, which can make your life easier, like on how you want to select your meshes or make selections. So as of now, what you can do is you can make selection based on the position and the normals and a few different, like based on the textures and index numbers. By bringing in normal here and plugging this into selection, what I'm basically telling this mesh to points is that based on the normals direction, we are going to assign the selection. So now that we have a normal input into the selection, so this mesh to point is reading the normals information. And now if I bring combine XYZ and separate XYZ, sorry, and disconnect this one and only take the Z input. So in this vector, the selection vector, we were using the normal. So it was using all the normals, the X direction normal, Y direction normal and Z direction normals, and placing these orbs everywhere, these spheres, the points. But what we did here is disconnected the X and Y, and we are only using Z here. I'm pretty sure someone out there must have a better solution for this, or even I'm new to geometry nodes. I'm never sure of the best method to do the things. But more or less, this should be the principle as of now, like how you select things. Now we have the points scattered on the Z direction only, the top and the bottom. So I'll add this math function here and try out few different things. So I tried a few things. Usually for things like this, like if you want to select the top or the extreme tops and the bottom, the minimum, maximum and the seal and floor, these things work. So I'll choose the ceiling and the seal and try to clamp it, and that worked. So it's basically taking the seal, the top, and if you want to choose the bottom one, then you would have to choose the floor. And yeah, so it's quite literally self-explanatory in this case. But then later on, when I tried more and I experimented a little more, so what I did was, instead of using the combine XYZ, you can also use just the Z input into the selection. and I think it's taking only the positive value of the z-axis, and that also works. So maybe in some complex examples, this using the directly into the selection might won't work. So if you're dealing with the different axes, then you will have to go through the process of separating xyz and combining xyz and then play with the connections in between. All right, there is always a better method to deal with the things, and everyone just keep on coming up with a better method, and that is what we are doing here, just learning from each other. And one more thing I would like to do is these points that we have scattered, I would like to push the position of these points a little further. So I'll plug the position in here and bring in a multiply node with the math multiply. Sorry. Yeah. So it's working in all the directions. So we will have to do the combine XYZ again and choose the Z direction. Sorry, Z direction here. So what I'm doing here is basically exaggerating the position, whatever based on whatever input the position is assigned. So we can just multiply that. So you would see a little curve going on here, but here we have much more aggressive curve, and you can play around with any kind of, I mean, depending on your taste, you can just tweak this out. All right, now if you're having fun with all this, then what you can do is add one more layer of instances. So distribute points on faces, and this time we are going to use these small spheres that we distributed right here on top of these bars. So let's just bring a frame first so that we can organize stuff, and so much more readable now. And now let's plug this distribute points on faces and plug the original geometry into the join geometry node. Instances on point, then instances on point. So for some reason I'm not able to see instances on top of this. It should be able, I mean, it should have been working, but something strange is going on. So just in case if this happens, what you can do is you can log these instances, like I mean realize these instances instead of like copy of the same object. This becomes one mesh. These won't be considered as instance now after this point onwards, and these will be realized as geometry. So if I scatter point on these, then it's going to be like how we originally scatter point on this grid. So instead of clones of one icosphere that we used, all of these icospheres will be used as one geometry for instancing. So if this is just a solution in case the instancing is not working for you on the third level. And now just put this into here 0.02. Yeah, increase the density, and now you can see this entire field is just field of orbs is working as 0.05. Increase the, let's just set shade smooth. So I would like to smooth these things out. Yeah, it looks much cleaner. So let's increase this to maybe 8,000 or something, and everything looks pretty equally scaled. So what we can do is bring a texture and plug this right into the scale. There you go. So according to texture, these things are going to scale up and down. The only hiccup we had was this realize instances. Without this, even without this, we should have been able to scatter things on top of these spheres. But anyways, but just in case if you run into an issue, just realize instances, much more cleaner workflow. So I think more or less we are done. All we need to do now is just add few materials. So let's go to the material section and set material. Something like this. All right. So let's set, I believe this wire is for the ground plane. Yeah, this one is for the ground plane. So let's select the plane material here and this wire is for the bars. So if you are confused here, go back to the material part. I think it was chapter number 4. All right, so select the bars here, select the orbs and the small ones. So press H to hide these, organize these, and I think more or less we are done. We just need to set up a few things for the rendering. So I won't be creating materials from the scratch. Instead, I'll give you a quick breakdown of what is going on, because honestly, these are very basic materials, nothing you can't create on your own. So for the ground plane, I'm using a pretty flat principled BSDF just with a blue color so that I could get this blue bounce, which goes well with this kind of hue that I'm using on the other objects. And on the bars, I'm using a metallic shader, and for randomizing the colors, what I did was used a hue saturation node with this kind of color, and in the saturation and hue I used object info nodes random value, so that for every bar there will be a random value generated for this color. And by default the hue is 0.5 in hue saturation node, on which you get this color. So what I did was I played around with the values around it from 0.4 to 0.6. On 0.4 you get a slightly bluish color, 0.6 you get warm colors, and use that those values into this map range to limit the hue saturation's randomization. So there is not really a drastic change in color going on, but very close to the original state of the color there is a little hue shift going on, and which looks fine for this visual. All right, and you can use the same for the saturation as well if you want to increase or decrease the saturation based on the different for the random bars, or it's totally up to you. Play around with the materials. And then there is orb. So in the orb you can actually ignore this emission shader, and this was very specific to one shot. So in the orb I'm using volume scatter and volume absorption to just like how we create basic volume shaders for the clouds and everything. So again, for randomizing the colors of these orbs, I'm using I'm using this texture. So I'm using this texture on these orbs. Let's select this orb so that we can, let's see if we can preview some of this stuff. So I'm using this Musgrave texture and in the volume, and to randomly generate a scale, different scale for different orbs, I used this into scale, the random object info node. So some of the orbs have more texture, some orbs have less texture, and then I used that into the color and added some of the colors with the color ramp node. And similarly for the volume scatter, I'm using same texture for the density. So some orbs have more density, some orbs have less density. So for the main surface, I'm using the glass shader, which is on top of everything. And yeah, that is all there is to it. And let's see if we can preview this without interrupting the audio. So yeah, for the glass, I'm using a noise texture to add some imperfection on the glass, so that some of these smudges and the texture is basically breaking on the glass orbs. All right, so very simple stuff, and I'll leave the screenshot here if you want to replicate the same thing. And yeah, that's about it. So once you have everything, just go to the Rendero. So now that I have everything, I just go to the Rendero and turn on my computers, open my Blender, open my files here, and start rendering stuff. And make sure you save your files somewhere on the cloud workstation, or if you're using some Dropbox or something, FTP, then you can save it directly there as well. And then just start rendering. So since the GPUs are much faster, I can quickly see the previews here. So I really enjoy working on being able to render things quickly with these cloud-based workstations. So do check out, the link is in the description. So once you have everything set up, just play around with the different views, different camera settings, add depth of field, just find the right angles, find the right animation. And what you can also do is go to the geometry node editor and just play around with the different values for the map range and find the different combination of the texture and the patterns, and maybe try different transitions or something. Maybe you could start with having a bigger wave, and then which emerges and makes things like maybe you can start off with a flat grid like this, and then slowly add texture to this by scrolling the noise texture, and there you go. So you can add more interesting transitions and everything. And yeah, then obviously the camera plays the big role. Find the right music, add some nice camera angles, and try some orthographic views, some perspective views, depth of field, add change the lighting, maybe try to animate the lighting and everything. So it doesn't matter how simple the effect is, complexity of the scene is, you will also have to invest some time into adding some more value into the visual, the lighting part, the camera shots and everything. So at the end of the day, all of these tools, geometry nodes, particles, they will give you a certain result, but that is not everything which is there into creating the visual experiences. So you might won't want to leave behind the other aspects. So just invest some part in it, add some interesting lighting, some HDRs, just play around with it. Now this was a very simple example of cubes scattered on top of plane. So how about layering this effect to distribute many different kind of objects on top of each other to make complex scenes? Now just a food for thought, how about a layer of scattered different stalls in the market, and then these stalls can have baskets scattered on the countertop, and these baskets can have fruits scattered in them, and these fruits can have labels scattered on them, and few maybe dewdrops or maybe dust and paper on the street, posters on the wall. It sounds interesting, right? It's just a matter of time, ideas will start to kick in, and there would be no limit to how much you can detail in the layers. Artistically speaking, technically there will always be a limit of what computers can afford to handle. So try it out, let me know your thoughts and share your results with me on Instagram. Tag me with Crossmind. Before you skip on to the next chapter, these files and the previous examples that we have discussed in the series and the future examples which we are going to add later chapters in this series, all of that will be available on the Gumroad if you'd like to get these files. So if you get this now, you can get all the future updates files for free without having to pay any additional cost. So far we have discussed only the simple ones, but plenty more will be added to this series, and it will go on for quite some time. So if you'd like to support this channel and this series and make more possible, hit that Gumroad link in the description right now, and you can also join our YouTube channel. In next few chapters, we will discuss a few more examples of instancing and scattering on points and talk about how you can create detailed scenes or motion graphics with it. If you are new to Blender, try out our introduction series to get you comfortable with the basics. And if you haven't seen the previous chapters of this series, I would suggest that you watch all of these chapters in the right order. And if you get lost at some moment or making some error, don't forget to check out the comment section, the pinned comments, and you can always press Ctrl F to find a keyword which you are looking for and search out the comment section. I might have answered it already. If not, then I will try to get back to you as soon as possible. So I will see you guys in the next chapter, and we will create a little more with whatever we have discussed so far. Just a few exercises to warm you up and keep you excited with all this complex information of geometry flow, the geometry nodes. So stay tuned, subscribe if you haven't subscribed. I'll see you guys in the next chapter. Bye bye, take care.